Hey guys, welcome back. We had a bit of a bad run over the last couple of weeks. My spray vat has sustained some pretty severe abuse over probably the last 4 years. One huge piece of advice when you're spraying is to not use your PTO clutch as a stop-start mechanism for your spray vat. It's a big mistake. So what happens is all the inertia trying to get that heavy equipment, the PTO knuckle and everything to spin, it needs a gradual build up and not a lock in and try to spin at the full rotation or 540 RPM. So if you try to jam something that's spinning at 540 RPM into a stationary object, it's not going to be good for that stationary object or for the thing that's spinning at 540 RPM. That's exactly what used to happen to the spray vat before I come along, and as a result it's smashed a cog inside the gearbox. That cog at some point has come loose and it has just shredded everything inside the gearbox. The spray vat's so old the replacement parts no longer exist, so what we've had to do is purchase a new spray tank, which is not a cost that we like to wear, but it was necessary, so we had to do it. Anyway, what that does mean for you guys is you get to watch me calibrate a spray vat. Any new equipment especially needs to be calibrated before you put it out in the field. You can't just assume that it's going to do the same as your old equipment, and we'll run through the calibration process, and I'll show you the workout sheet that I use, and it just makes all the math nice and easy, and there's no point in overcomplicating anything, I don't think. So if you can make something easy for yourself, why not do that? It's Monday at the moment. I've just been in doing a few tune-up jobs. I'm about to head off home. I'm not catching a bus home. This is just something that we have on our property, and I was going by and I thought, why not? May as well just film this intro in here. Anyways, yeah, just watch along, and hopefully I'll be able to help you if you don't quite understand how to calibrate some equipment. It's a necessary skill, and it's something that can be quite daunting the first time you try to do it, but once you get into it, the math really isn't that hard, and it's quite simple to do the calculations. Hope you enjoy this, and remember, if you do enjoy this, please maybe consider liking and subscribing. It really helps me out. Anyway, check it out. I'll just do the one, I reckon. See what the output of these nozzles are. Technically you're meant to do both though. Might do both. No, it shouldn't. Is there water going into the tank? Got my fingers crossed there with 2.7 in there. 2.7. bad though, 23. Yeah, sweet, no, that's alright. Yeah, at least.
Hey, here we've got a 100-metre stake, which has fallen over at some point in the wind. And the reason we have this 100-metre stake, and the starting point being at the signpost down there, is because regular calibrations are an important thing. And if you've got a spot that's set up to do your 100-metre timing, if you've got a spot that's set up to do your 100 metres, then it takes that process of having to measure it every time out of the equation. And the easier that you can make the process, the more likely you are to do it on a regular basis that you're meant to do it. This is a thing that a lot of people let lapse. You should be calibrating it probably twice a year at least, sometime in the middle and at the very beginning, because your spray vat hasn't been used in some time, and you also want to calibrate it again after it's had some use. This also lets you know if there's been any problems with the machine at all. And I know that I set the gearing ratio at the 100-metre mark down there, and when I cross this line I've done 100 metres, and it makes the whole timing process a lot easier. So anyways, I'm going to go and do the 100-metre sprint. The sprayer has finally arrived. The next step for us is to calibrate it. Now we've been out already, we've measured the output of each nozzle and how we're going to have it set up initially. Our required output at the moment is 600 litres total, so that's what we're calibrating our machine for. And basically we've gone through, we've measured the output, we've done the speed, distance travel and all that sort of thing. So the next step is to fill out our calibration sheet. And our calibration sheet is very simple, step-by-step process. This is the old sprayer, and we'll look up a new calibration sheet. This is what we want. Okay, so the date today is the 16th, the 10th, 2019. The spray unit is the new Zebra Hardi 600 litre tank. And the tractor is the Fendant, and our gearing ratio is slow, rabbit, first. Our RPM is 2,260, and that puts our PTO speed at 540 RPM. And our pressure is set at 6 bar. Nozzle manufacturer is Hardi. And if you have a look on the chart just here, the nozzle type is 20, and I put blue in brackets. Specified output is 2.67 litres per minute. Number of nozzles in operation is 6 total. Combined output 16.5. 16.5.
and it took, with the rev set where they are and the gearing ratio as it was, at that speed took me 60 seconds to drive 100 meters, as you'll see in the replay here. And I timed it, 60 seconds, 100 meters, and seconds it took to travel 100 meters, 60. Therefore, your kilometers per hour is 360 divided by, and there's an arrow pointing up, which is 60, and that equals 6. So we're traveling at 6 kilometers per hour, and that's the magic number. Now we do the math down here, amount of water per hectare, and then our first answer is total output litres per minute, which is 16.5. So we clear this. No, we'll click at that. 16.5 times 6 divided by our speed, which was 6 kilometers per hour. That equals 16.5 times that by 100 and divide it by our row width, which is 2.75. That equals 600. And that's the amount of water sprayed per hectare in litres per hectare. So at the moment our output is exactly 600 litres per hectare, which is where we want it to be. Oh, it's been a long day. There's been a fair bit of stuffing around with the new spray vat, trying to figure out how things work, and there'll be some fine adjustments when I'm actually spraying. This new sprayer has a really good aspect to it, and that is that you can change the direction of the wind next to each nozzle. So what tends to happen with the spray vat, if it's operating at full blast, it can sometimes shingle the leaves. If it's got a direct airflow pushing on the side, it'll push all of the leaves down flat and create a shingling effect, and making it nearly impossible to penetrate up behind the leaf. But what this new spray vat has is a directional vane, so that you can change the direction of the wind. So you can make it as though when the sprayer goes past, the wind, instead of blowing straight, is blowing in opposite directions and rattles the canopy, and that really helps the spray push all the way through the canopy wall. And this is quite an important step when it comes to spraying, because without that penetration, a lot of disease can develop inside. It'll develop inside the canopy, and it's not always that easy to detect. So the outside stays relatively clean because it's protected with the preventatives that you put on if you're taking that commercial approach. And with that shingling effect, often the disease can develop on the inside of the canopy. This can come from heaps of different reasons. The canopy not having enough pressure and not putting out enough pressure, just not acting right in general, or that shingling effect that I just mentioned. Often it is that shingling effect that creates the problem, but with this new wind directional aspect to the new sprayer, it'll really help us to punch in some canopy there. Anyway, I hope you've enjoyed this video. Please consider liking and subscribing. It really helps me out, and I can't wait to see you all on the next video.